Topic 21. Inequalities. An inequality states that two quantities either are not equal or may not be equal. The way you have been familiar with inequalities before have been in using the inequality symbol. This symbol is the less than symbol. This one is the greater than symbol. Less than or equal to. That's what the definition up here meant by may not be equal, because in some instances it can be, and that's what that line underneath the less than sign stands for, that it can be less than or equal to. And of course we also have a greater than or equal to. So these are our inequality symbols. An inequality may have more than one solution. Together, all the solutions are called a solution set. So what we're going to do today is we're going to learn how to solve simple one-step inequalities and be able to graph or recognize the graph of their solution sets. Inequalities are solved exactly like equations. What you do to one side, you have to do to the other. You still pretend that that balance is there. The only thing, instead of dropping that equal sign each time, you're dropping that inequality sign each time. And there is a special circumstance, and we'll talk about that when we get there. Any questions so far about the notes for today before we get started actually looking at some examples? Because we're going to do an example from each operation, an addition, subtraction, multiplication, and division. Questions? Now remember, if you're avid, you're coming off to the side and you're writing a question. What is an inequality? What do inequality symbols look like and stand for? What is a solution set? And you're making your questions for your Cornell notes. Example 1. X minus 12 is greater than 32. Now, we said that inequalities are going to be solved exactly like equations, so this is where that imaginary balance is going to be. We're still going to do what we did before and undo what was done to the variable by doing the inverse operation. So if x, we have subtracted 12, what's the opposite of subtract? Add. So we're going to add 12 to both sides. So we're still doing the same thing. What we do to one side, we do to the other. We do the opposite. So that cancels out and leaves x by itself. We're dropping the inequality symbol instead of an equal sign. That's the only difference. And this is going to be 44. So this is what it meant by there's a solution set, not just one answer. When we were doing equations, x equaled something, and that was the only thing x could be, and when you plugged it in, this side was exactly the same as this side, and when we checked it, that's how we knew we were right. But now, any number that is bigger than 44 will make this a true statement. Will 44 make this a true statement? (44 minus 12), what is that? 32. Is 32 bigger than 32? 32 greater than 32? No. So that's why every number that is bigger than 44 are the only ones that can satisfy or make that a true statement. So when we look at the number line and what our solution set would be, draw a number line. Now obviously, number lines run to infinity in both directions, positive and negative. I'm only going to put a few numbers on this number line that will include the number that I want, which is 44. So if you're making your own, that's your goal, that your number line has to have a couple on either side of the number that you're looking for. Most of the time when I'm allowing you to practice, I will give you these number lines so that you don't have to create them on your own, which is a plus. Now, the way we're going to graph it is 44 is the number that we want. So we're going to put a circle around 44. Now, if 44 could have satisfied this, if it was greater than or equal to, I would have colored it in because 44 could have been part of my solution set. But we just agreed that 44 will not make this a true statement. 44 is not part of my solution set, so I'm going to leave it open. I'm not going to color it in. If this had been equal to 44, I would have colored it in. And that way anybody looking at the graph would have known if it's a closed circle, 44 is part of the solution. And now it's any number greater than 44, so you're going to color that line in that direction. Because every number bigger than 44, even 44.1, and that's why these numbers in here, before you get to 45, have to be included. Because any number, even a fraction of a part bigger than 44, is still going to make this right. Make it a true statement. So we've solved it and we've graphed it. Any questions about number 1? Now again, we're using just whole integers. We're not using fractions, we're not using decimals yet, but that's why we start with the whole numbers, so that you learn the procedure and the concept, so that when the numbers change and the numbers get harder, they get bigger, they get to be fractions and decimals, you'll still understand how to do it. Example 2. X plus 16 is greater than negative 2. This would be our imaginary balance. Again, we're solving them just like equations, so we're still going to want to pretend like that is there. What you do to one side, you do to the other. What has been done to x? We've added 16. What's the opposite of add? Subtract. So we're subtracting 16 from both sides. That's going to make 16 zero pairs, which cancels them out. X is left by itself on that side. We drop the greater than sign. Now, in order for us to solve this side, we keep, change, change. It was subtraction. That makes these the same, and if the integer sign is the same, you add. 16 plus 2 is 18. And because they are the same negative, it's negative 18. So now it's solved. The only thing we have left to do is graph it. Again, you have to have just a section of the number line, as long as the number that you need is on there. However you make it is fine. So, we put our circle around negative 18. Is negative 18 included? No. We did not say it was greater than or equal to, we just said it was greater than. The only time you color that in or close that circle is when it is also equal to that number. So now x is everything bigger than negative 18, so these are all the numbers bigger than negative 18. Example 3. Z is divided by 6, or Z6 is less than or equal to 7. What has been done to Z? It's been divided by 6. The opposite of divide? Multiply. We're going to multiply both sides by 6. This reduces down to 1Z. I drop my less than or equal to sign, and 7 times 6 is 42. And because the signs were the same, it's a positive 42. Now our number line. Just draw out a quick one as long as your number is on there. 42 is the number that our circle goes over. 42. Is 42 included? Yes, because it says Z is less than or equal to 42. When it's included or equal to, you close the circle. You color it in. By coloring it in, that tells me that 42 is part of the solution set. And now Z is anything less than or equal to, and less than numbers go in this direction. So that's the direction you color your line. Now I'm going to talk with the last example, even though I could have talked about it here, because it's only it only applies to multiplying and dividing. And I have seen this on NC check-ins, on MAP assessments, like the major assessments you take in the fall, winter, and spring, and I have seen it on the EOG. So, example 4, and let me give you this exception before we do example 4. If you multiply or divide by a negative number, the inequality symbol flips. And again, it's only with multiplying and dividing, and it's only with a negative number. Now again, I'm going to tell you the same thing I told first block. Don't ask me why. This is just a rule I had to memorize. My teachers never explained to me why you did this, why the sign flipped, and I was never curious enough to find out the answer on my own. All I did was just memorize that this was a rule that you had to do. So what did a student in first block do? They asked me why. So I'm going to try and find out the reasoning behind why, when you have to multiply or divide by a negative number, the inequality symbol flips. And if I am successful at finding that answer out for him, I will also share it with you. But for right now, just understand that's a rule and that's something that you have to do, because you better believe that both of those answers are going to be answer choices, with the symbol the way that it was and the symbol the way it should be when you flipped it in the answer. So let's do the example for this with our multiplication problem, which is example 4. Negative 5z is greater than negative 15. This would be our balance. What has been done to z? I have multiplied it by negative 5. What's the opposite of multiply? I'm going to divide by a negative 5. And just as soon as I write that I have to divide by a negative or multiply by a negative, I'm going to flip that sign. So now if I divide this side by a negative 5, we know that that reduces down to 1 and leaves z by itself. 15 divided by 5 is 3, and because they are the same sign, it is a positive 3. So this says that z is less than 3. So here we divided by a negative, so we flip the sign. We're still going to graph it the same way. Three is the number I want. That's where my circle goes. 3 is not part of the solution set. It does not say that z is less than or equal to. It just says it is less than. So my circle is open. And it's any number smaller than 3. And they go in this direction. Any questions about the solution or graphing the solution set? Okay, the practice that I have for you is solving the inequality, which they are going to ask you to do on the end of grade test. They will not ask you to make your own graph for the solution set. You are going to do it now though, so that that is part of your standard course of study, that you know how to do it and that you can do it with proficiency. But the way that they're going to ask you to identify that solution set is like this on the EOG, where you still have to find the solution, but then you have to identify which one of these is the correct graph for the solution set in a multiplication form, in a multiple choice format. Any questions? There are 8 on each side. It doesn't matter which side you start on. Again, any questions before I come around? Okay, once you get started, if you have questions, raise your hand and I'll come around and help you.